Welcome to Gabversity. Hello everyone, let's see who comes. It's a beautiful day here. Hello, lovely to see everybody. So, welcome to Gabversity, where facts took the car and drove off, leaving feelings at home crying in the corner like a little biatch. So, let us begin. First question. We have a distribution. Here is the distribution, and we have Booz and Byron. Lovely to see you, and lovely to see everyone that's here. We have one 14-year-old, one 15-year-old, three 16-year-olds, two 22-year-olds, two 24-year-olds, and five 25-year-olds. Here it is. All right. This is the room, and what we want to do is calculate J squared. What is J? Well, J, we want J, and we want to square that. Well, we have, what do we want to do with that? Well, we're going to have N14 okay, and this is the age of 14-year-olds. That's the number of 14-year-olds, the number of 15-year-olds, the number of 16-year-olds, the number of 22-year-olds, the number of 24-year-olds, the number of 25-year-olds, and what does that equal? Well, this equals 1. There's one 14-year-old, one 15-year-old, three 16-year-olds, two 22-year-olds, two 24-year-olds, and five 25-year-olds. So for J squared, what we want, right, this implies that J squared equals, we're going to add all of these up because that's J, right, and then we're going to square it. So 1 plus 1 is 2, plus 3 is 5, plus 2 is 7, plus 2 is 9, plus 5 is 14. Now I've missed something. Ooh, I've missed something. 1 plus 1 is 2, plus 3 is 5, plus 2 is 7, plus 2 is 9, plus 5 is 14. What have I missed? I've missed something. There's someone in the room that I've missed. Who have I missed? Can't actually see what I've missed. Or have I? Interesting. I've missed something. Maybe 1 times 1 is 1, times 3 is 3, times 2 is 6, times 2 is 12, 5 12 is 60. No, that also doesn't work. What have I done? Unless the answers are wrong. I think the answers could be wrong. I actually don't know what I've done wrong. Oh no, hold on. Plus. I don't know what I've done wrong. There you go. So that's my first question. I've already stuffed it. But that's not right. How did we get 21? I must be missing some data somewhere. I'm definitely missing some data. 1 plus 1 is 2, plus 3 is 5, plus 4 is 9, plus 5 is 14. And they're saying the answer is 21. That means I'm missing 7. Oh, hold on a sec. 1, 2, 3, 4, 5, 6. Ah, damn it. NJ represents a number of people of age J. And we want the sum from J equals 0. They've made a mistake, man. I'm telling you. I'm telling you now, they've made a mistake. J squared should equal 14 squared, which equals 10 plus 4 squared, which equals 100 plus 80 plus 16, which equals 196. That should be the answer. I don't know why they're saying 21. I think I might have missed something. I really don't know what I've missed. That's pretty disappointing, I have to say. 1, 2, 3, 4, 5, 6. Yeah, I don't know. I don't know what I've done. I'm going to have to just keep going and look at that later. Because now we want j squared. So that's the variance. That one is quite easy to solve, because that is just 1 over 14. 1 over 14 outside of, and then we got all the ages. So the ages are, we have 1 that's 14, so that's 14 squared. And then we have 1 person that's 15 years old, so that's 15 squared. We'll try 5250. And how many do we have that are, we have 3 times 16 squared, because there were 3 people aged 16. Benvindo. Alright, and we have 2 people aged 22, so that's 22 squared times 2. And then how many 24s? We have 2 24-year-olds. So plus 24 squared times 2. And then the next one we have is Amy Loren and family. Plus, we have how many 25-year-olds? 5 of them, so 25 squared times 5. And that equals, if I add all of that up, that becomes 1 over 14. It's wrong because I'm 32. That is 1 over 14 multiplied by 6434. And that equals approximately 459.571. Okay. Alright, so that is j squared. That is fantastic. Next question is determine delta j for each j and use equation 1.11 to compute the standard deviation. Alright, let's do that. So we are now going to make a table. We have j, which is the age, and then we have delta j, which equals j itself minus the average of j, because we want to see how far away we are from everything. Now for some reason the average is 21. That's the part that I'm missing up. I'm pretty sure it's, they're saying it's 21. The average age is 21. Ah, I got it. I figured out what the problem was. Because we have 14 plus 15 plus 3 by 16. So 3 times 16 plus 44, which is 2 by, because there's 2 people aged 22, plus, you didn't calculate the expectation value. This is true. 48, which is 2 by 24, and 5 by 25 should be 125. Alright, what's that add up to? That's 29, plus 30 is 59, plus 18 is 77, plus 3 times 16, yeah, absolutely. 77 and 50 is 125, because that's 48, and then 125 is 250, and then 250 divided by 7 to 20 is 140, 147 over 7. I don't know, maybe I should actually get a calculator from now on. But anyway, we know that the average age is 21 because I figured out, I'll come back to you when you figure out time travel. Sounds like a good plan, my friend. I was thinking the average age is 21, but there are more people who are 2 plus 2 equals flat Earth. That's funny. So there are more people who are 25 than there are 14, so the average age is not going to be 16 or 17, it's going to be pushed upwards, which gives us 21. So I figured out that's where the problem was. I didn't factor in that there were more people in the room that were older. So the average age is higher. Alright, so what we do is now let's make this table of all the ages. So we have the ages, we have 14, 15, 16, 22, 24, and 25. These are the ages, but then we have the number of them minus the average. Okay, that's delta J. So let me just fix up this table. Alright, what type of pen is that? Yeah, it's a pretty cool calligraphy pen. It's a calligraphy pen from Pilot. It's a Pilot calligraphy pen, and I think it's about 1.5 mils, or 1.5 mil or 2 mil. There's another one I have that's really good, but I'll use it next time. It's downstairs. Alright, so delta J equals J minus the average of J. And the average is 21. Oh, you are more than welcome, my friend, anytime. So this is 14 minus 21. This is 15 minus 21, 16 minus 21. This is boring. 22 minus 21, 24 minus 21, 25 minus 21. And that should equal minus 7, minus 6, minus 5, 1, 3, and 4. Okay. You should put a link in your profile with an Amazon affiliate link. The profit. Oh yeah, I didn't even think of that. It's a good idea. Look at you, bloody brilliant capitalists, mate. Here I am, just some silly physics undergrad. Alright, so now we want to calculate theta squared. Alright, this is going to be fun. So theta squared, right, which is the variance. The variance, which is theta squared, this is just statistics, mathematics, right? It's 1 over n, which is 1 over... why is n equal to 14 all of a sudden? Now I'm confused. 1 over n, nj. What have I done wrong? 1 over 14. 14. Oh yeah, sorry, because it's the addition of all of these. So we've got 1... how many people we have in the room, that's how I get 14. So it is here 1 plus 2 plus 3 is 5, plus 2 is 7, 2 is 9, plus 5 is 14, so n is 14. So that's 1 over 14, because that's how many people there actually are in the room. And 1 over 14, hey, True Faith is back. So 1 over 14, and then what we're going to do is put all these numbers inside the equation, because remember your ground set is 14. Absolutely. Absolutely. Bingo, my friend. So now inside, we are going to put minus 7 squared, which is 49. Minus 6 squared, which is 36. Minus 5 squared, which is 25. 1 squared is 1. 3 squared is 9. 4 squared is 16. And then we close brackets. Alrighty. And so we get 260 over 14. 260 over 14, which is approximately equal to 18.571. And so therefore, the standard deviation equals the square root of, so 18.571, square root of that, which equals again approximately 4.309. Alright, so that means that if the average age is 21, we have a deviation of 4.309 on either side of the distribution. So in other words, it looks like, let's say that here's the average age, right? We're going to have a deviation for most people of this here is going to be 4.309. So we're going to have ages from, all the way down between 17 and 25 possibly. Not a bad age to be. Yeah, physically it's okay, I guess. Mentally, I'm happy to get older. It's one of the benefits. It'd be good to have both. Alright, so C. What is C? C is use your results to check equation 1.12. Okay. And, sorry, 1 second. So when we did the first equation, we got 459.571. Let me go back and show you the first equation here. First equation was to find the variance, so we used the original equation, which was 1 over 14, which was the number of people in the room, by the ages of each person and how many of them squared, and we got 4.59.571. And so now we'll do it the hardcore way, which is like this, which is j squared minus j squared, and that equals 459.571 minus 441, which equals, guess what? I use this for approximately in my maths. Ah, yeah, you can use that one or the other one. Yeah, your one's prettier, but it's just harder work, so I just use the other one. All right, so which equals 18.571. We'll have a look at that. 18.571, right, because that's the standard deviation, equals that. And so therefore standard deviation equals that, right? But have a look. We had the same answer, 18.571. Sorry, that was the variance, not standard deviation, sorry, variance. Yeah, so variance 18.571. So we got it. Excellent, problem solved. Let's look at the next problem. They're going to get harder, so prepare yourself. All right, consider the Gaussian distribution. Here is a Gaussian distribution. It is P of x equals a e to the minus lambda. They're definitely not as pretty, that's for sure. By opening a beer, awesome. That's what you need, my friends. That's how Einstein did it. If you've anyone seen that movie, Young Einstein, he uses beer minus a squared. Alrighty, so these are all positive and real. Positive and real, positive and real, positive and real. Okay, so they're on the real number line. Use equation 1.16 to determine a. Okay, well, what we have to do, I believe, is use equation 1.6, which I don't have with me, but I'll try and figure it out. What I will say, let's use the equation that equals 1. We'll say the integral of that equals 1.
She wrote the wrong day down.
All right. So equation, I would say we have to normalize it, so I don't know why they're not squaring it. I'd rather just have a look here. All right, let's do this integral, right? If anyone's ready for integral calculus, we're gonna make, this is the probability function in a Gaussian distribution. We're gonna say that equals 1, and that's how we find a, right? So by definition, we're gonna make that equal 1. In other words, the probability of finding the particle somewhere is 100%. And you've seen my older lectures. I'm not going to explain it again. If you've missed it, go back to the last lectures. And you guys, it's awesome to see you. But yeah, it's okay. It turns out that sense of humor is only in 50% of the population, according to Scott Adams. So let's just say a e to the minus lambda, let a to minus lambda x minus a all squared equal 1. And we're going to let the integral of that actually equal 1. The integral from minus infinity to infinity. So what we're saying is, if we integrate this, the chance of finding it is 100%. Cool bananas. So now let's integrate this mother. So what we could do, we want to make this easy. So we could say, to integrate this, now we're going to see some real integration. Let x minus a equal u, which implies that du equals dx, if you just derive both sides. And so therefore the integral converts to this, so which implies that 1 equals the integral of minus infinity to infinity, It's still minus infinity to infinity even when we write it in u, because infinity here is the same as infinity here. All right. Now, what do we got here? X minus a all squared, that becomes u squared. So that becomes a e to the minus lambda u squared. Okay. Du. And now we have to integrate this and get u. That's going to be interesting. How would we do that, I wonder? We use integration tables. Are you a stats professor today? Yeah, today I am. It's going to get more and more into quantum mechanics as we go. How do I get u? You lost me on that. You lost me, my dear friend. So, if we use the table of integrals, we can say 1 equals a outside of minus infinity to infinity of e to the minus lambda u squared du. And we know from the table of integration that this should be, if I get this right, a equals, it's probably best that way. Message me anytime, my dear. You're probably too fast for me. You probably think a lot in your head, and like you skip all these thoughts, like the working. So my brain's like, what? A equals, we got pi over lambda square root 1 over a. Not bad at all. 1 over a equals that, and so a is left with that. That's exactly what I got for a, from minus infinity to infinity of that. Now there's a couple of different ways to do it. Hello, my friend Ed Murphy, welcome back, brother. A equals that. So we've solved for a using integration tables. What I really want to do is actually solve this in a straight way. But what I'm thinking of doing is, hold on a sec. I'm actually thinking of doing a pure calculus course as well. At the moment, we're just doing some Gaussian wave equations for quantum mechanics. But later on, I will do a calculus lecture which actually goes through all of the steps and different ways of solving integrals. You know, using like Lorentz transformations and stuff like that. Oh, thanks. I know, I gotta get it sorted. All right. All right, let's look at the next one. B. What is the probability? Oh, sorry. Find x squared, and standard deviation. I really like those shades. Thank you. I found them. I always find my stuff. I'm not really good at. Laplace transform. Sorry, I said Lorentz transformation. I was confusing Einsteinian relativity. Yes, Laplace transformations. Absolutely. Absolutely. We are all math students today. All right, let's look at x. How do we calculate x? Well, we know that the formula for x is the equals a outside the integral of minus infinity to infinity of x e to the minus lambda x minus a all squared dx. All right, so this we know because all it is, if when you want to find x, it's that equation, but you put an x in there, and that's what we got here, right? This is now we're solving, this is quantum mechanics equations, right? So they're basically, it's a combination of calculus and statistics, and they chuck them together because we know that the quantum particle's not always in the same place you expect it to be. All right, here we go. So now let's integrate this bad boy. What we can do is we can say, let me try it my way, let x minus a squared equal u, which implies my electrical engineering courses. Oh yeah, you would have. Yeah, I can imagine. They're pretty good. All right, so therefore, which implies that du dx is going to equal 2 outside of x minus a. Okay, so therefore du equals 2x minus a dx, and so that's not going to work. That's a bit too complicated for this one. What's another possibility that I can do? Ooh, I just figured out what I can do. All right, I have a better idea. So what I'll do is, to make it simple, we will say let x minus a equal u, which implies that du equals dx, because you're just deriving both sides. And then the equation, so therefore a outside the integral of minus infinity to infinity of x e to the minus lambda x minus a all squared dx actually equals a integral minus infinity to infinity of that would be u plus a. It should be, yes, because if you want to put x on its own, this a comes over here and becomes positive, so it becomes u plus a. So that x becomes u plus a. So u plus a outside of e to the minus lambda u squared du. All right, so we've just solution for continuum hypothesis. Your best guess. I would recommend having a look at continuum hypotheses on YouTube, and there's some really good lectures. I was listening to one the other day, which goes for about an hour and a half. That's a pretty good one. Have a look at that. But these are all awesome questions. I'd love to do lectures on each and every one, if I could. All right, so where are we? So now we want to integrate this. We can integrate it by parts, I would suggest. What would be the best way to do that? We could use the integration table. Yep. I know what we can do. We can say that that equals a outside of the integral of minus infinity to infinity. Chain rule. Yeah, bingo. Someone's the man. Someone knows their stuff. So the integral chain rule, yes. Don Julio, I love that name. All right, so we're going to split this up first to make it simpler. All right, so we can say u e to the minus lambda u squared du plus integral from minus infinity to infinity of a e to the minus lambda u squared du, and then we shut that out. So now we've split it up to make it a bit easier. And then we know from before, let's have a look here. We know that because this one here is an even function, that's going to come out to be 0, and that's an odd function. And we've already done that one before. We know that that's similar to the equation we just did. So that's going to equal a outside of 0, because that's an even function. So when you integrate an even function on equal sides of the 0 axis, you're going to get 0. Calculating something specific. Good question. We are calculating a random exercise, but it's an exercise in distillation. So yes and yes. 0 plus, and we remember before that the equation a was that when we solve this. So if you have an a in front of it, then the answer is going to be a times that, which is right here. We have an a in front. So now that's just going to be a. What do you call it? It should be root lambda on pi. Let me check. Yeah, root lambda on pi. My undergrad is in math. Fantastic. So lambda over pi. Alrighty. U substitution, exactly. And because it's a definite integral, you don't have to substitute back. So that's the answer. So that means that we should get, what have I, hold on a sec, I've made it, oh no, that should be pi on lambda. Stupid me, always making mistakes. That should be pi over lambda, that's better. And a equals lambda on pi, which will cancel out, which will just leave you with a. So, which will equal lambda over pi outside of a pi over lambda, which equals a. So there you go. We found out that the answer is a. That's for x. Now we've got to find x squared. X squared is going to be a bit of a pain, which is the variance. That's the variance there. And the variance, we know, is almost the same, but we now, instead of putting an x in there, we're going to put an x squared. So here we're going to have x squared and then e to the minus lambda outside of x minus a all squared dx. Alright, so now we have to integrate this bugger, and we can say same deal. So we'll say let u, what should we make u equal to? Yeah, alright. You ever do any? I did for mathematical modeling. I did quite a bit of programming. Not really a fan, unfortunately. As much as I have a lot of admiration for those who can handle it. All right, so let once again u equal x minus a, which implies that du equals dx, and so therefore the x squared variance is going to equal a outside minus infinity to infinity of, and that's squared, so we're going to have to say u plus a all squared, I would say. Yeah, so that's going to be u plus a all squared e to the minus lambda x minus a squared, and that's going to be just the u. Du. Ah, beautiful. And now we just have integration by 3 parts, which equals a outside of, and because this you know, like this one here, that's when you open up the brackets, it's u squared plus 2a plus a squared. I'll do the long version for you, which equals a. Some of you probably already know this anyway. So that there is u plus a times u plus a, which is going to be u squared plus 2a plus a squared. And then we've got e to the minus lambda u squared du. Alright, so now we can break this up into parts. So we can have the integral of u squared by this, the integral of 2a by this, integral of a squared by this. You'll get all 3 of them. So let's write it out, my friends. Equals. Sometimes I'm tempted not to, believe me. A outside of, let's try and shrink this down to fit it in, integral of minus infinity to infinity of u squared e to the minus lambda u squared du, right, plus 2a, because we're now that one comes down here and we're expanding the whole thing. You are a good dude. Thank you. Likewise, my friend. Programming, having a strong math background is good for AI. Yeah, it's I hear that a lot. I reckon it's so funny because I really hated the subject, but I scored, I think, 100%. I smashed it, but I just didn't like it. Yeah, e to the lambda u squared. Alright, I'm really sorry guys, I have to go and answer this call. I'm getting like 3 or 4 calls from this same person, so I'm gonna have to cancel and then come back and continue this problem. Sorry, I'll see you in a few minutes.